At Callide Power Station, there are 4 coal-fired boilers that produce energy for Queensland. Each one of these units goes under maintenance on average once every 4 years, with each maintenance period lasting up to 2 months. A coal-fired boiler is typically around 16 stories tall and completely hollow on the inside. This creates a problem when it comes to maintenance, because the only way to search every part of the boiler for faults is to scaffold the entire core, which takes large amounts of time. Generally, as the area is scaffolded from the ground up, the engineering and maintenance teams check the boiler level by level as soon as possible, and when a problem is found, they will then put in a job for that section of the boiler to be repaired. The problem with this method, though, is that engineering and maintenance teams must wait for the scaffolding to be built before they can start their work. The second problem is that when a burst steam conduit causes an unplanned emergency shutdown, the teams must rush to diagnose and repair the damage, constantly weighing the risks of returning to service early against the money saved by putting the unit back online sooner. The solution for both problems is to use a small UAV to scan and photograph the interior walls of the boiler so the engineering and maintenance teams can inspect the interiors through the produced imagery, without the need for completed scaffolding. The scaffolding teams can then be directed to reach areas of the boiler requiring major repairs before the less damaged sections. The difficulty, though, in implementing this solution comes with the localization and navigation of the UAV, as it cannot use GPS inside the metal core of the boiler. Visual-based navigation will also struggle in this environment as the walls are uniformly colored and textured. For my thesis, I proposed to design and build a prototype UAV that can fly and navigate in a GPS and visual nav denied environment. My approach to address this problem is to firstly spend time researching and collecting information on the different types of sensors and methods of navigation used in GPS and VNav denied environments. Secondly, I will design a small UAV capable of lifting the navigational sensors and the high-res cameras required for the scans. Thirdly, my proposed methods of navigation will then be tested indoors in a large room or hall to scan the walls and create a visual map of the interior surfaces. If all goes successfully, final on-site testing could possibly take place, mapping the decommissioned boiler at Callide A power station in order to collect information on the UAV's performance in a real offline boiler environment.
Thank you for listening.